And we are live. Hello everyone. Welcome to today's workshop, Introduction to GraphQL by DataStax developers. This is Stefano and Aaron is here with me. So nice to see you all. And before anything, we should be having a sound check. So please tell me with a thumbs up if you can hear me and if you can hear Aaron as well. Before we start, no sound from Aaron. Okay, no sound from Aaron. Come on, this is the same. Oh no, I know why. Oh wait. Okay, so I know why. So okay, now we have sound from Aaron. Probably. Can you try?
Is there sound from me?
Okay.
Anyone?
Okay.
Anyone?
Oh, good. And fun enough.
I
Yes, I know why. Okay, we should be good now. Let me fix.
Oh, we're good now.
Are we good now? Sorry, I had to meddle.
I do see a couple of good now. Yeah.
Okay, so I think we are all good. Yes. Okay. So that was
All
okay.
right.
Great. So we can start. Welcome everyone.
Excellent.
Again?
Excellent. Yeah. Thanks everyone for joining us. You know, I'm sorry to pull you all away from World Cup.
Yeah.
You know, but
Which this year here is full of surprises, good and bad. But yes. Okay.
Yep.
So as I told you, I'm Stefano, developer advocate at DataStax. These are my contacts, and feel free to connect with me. That would be great. I'm a developer, an architect, and of course, I like and I love Apache Cassandra. I like to teach, to communicate, and yeah, everything distributed system is my interest. And that's it for me. So, Aaron?
yeah. Hello, I'm Aaron Pletz. I'm also a developer advocate with DataStax. I run the Apache Cassandra Corner podcast. So, hey, any of you out there have a great story about Cassandra? You know, I'd love to hear from you. Yeah, I, you know, kind of got my experience with Cassandra working for, you know, big retailers like Grainger and Target. And I've also worked as an author on a couple of books, 7 NoSQL databases in a week, and then the most recent edition of Apache Cassandra 3.x. So or mastering Apache Cassandra 3.x. So yeah,
so
that's me.
Great. Okay, thank you. Okay, so of course, today you see the two of us, but there is a whole team behind these workshops.
Yes.
And we acknowledge the contribution of everyone and say hello to all of our colleagues, our friends. And in particular, usually you see there is the YouTube chat. And today the chat is also, you will meet Cedric in the chat, who, well, actually, I think it's late night for him, but he is a night owl, as I wrote in the chat. So hi, Cedric. Thank you for being here. And probably there will be someone else at some point on the chat. But anyway, we will tell you something more about the chat in a little while. Okay, so let's start with a bit of housekeeping to know how to get the best from today's workshop. So this is live. Of course, we are now live, and we are doing this workshop live for you and with you. But in case you are not watching us live, that's because you're watching us recording, because this workshop will stay on YouTube for you forever as a recording. And that's why, so you can look at it and come back to it later and do whatever you want and play with the contents, the workshop content at your own time, convenience. Now, this workshop is interactive in various ways, mainly because you can ask questions. You see there is a chat next to YouTube. We are actively taking a look at it. There is a chat on YouTube. And please don't be shy, ask questions and tell us whatever you want to ask us. And the point is that when this video is over, the YouTube chat disappears. Of course, then we invite you to join us on Discord, and I'm going to drop the link to our Discord server immediately in the YouTube chat, so you can join us on Discord, and you will be able to have discussions with us, ask questions, and do whatever kind of interaction even later. So there is the DataStax Developers Discord, and most of the discussion happens there, of course.
Yep. And most of our team is like spread across the world. So if you ask a question in Discord, chances are someone will answer pretty quickly.
Absolutely.
There's always somebody up.
That's not the end of it, because we will also be asking you questions through Mentimeter, so menti.com. We'll give you instruction in a little while. And that's not only just questions, but at the end of this workshop, there will be a quiz. And if you answer fast and correct, you will get a chance to win some swag, some cool swag from DataStax developers. So stay tuned for that. Okay, so more about the content. Today, you will be doing everything that you will see on the screen. So this is not just a demo, this is a full hands-on session, and you probably, to get the best of today, you are going to do all of it yourself. Luckily for you, you don't have to leave your browser, because everything will happen on your browser. We have GitHub hosting the source code, the exercise to do, the instructions, and also this very slide deck for you. We will be using an IDE in the cloud, so again, in your browser, called GitHub, and you will see how cool is that later if you don't know it yet. Oh yeah, it is.
It is pretty cool.
We will use a database called ASTRA, which is built on Apache Cassandra, and it's not only Apache Cassandra, but it also offers a GraphQL API layer, a data API on top of the data. You will see it today. And that's it. Today, no Netlify except. So we are not going, so, okay, you will see later what Netlify is. So maybe that sounds a bit unclear to you yet, but we are using Netlify libraries, but not Netlify infrastructure today. But anyway, you will see more on that later. Okay, so something that is very important is that we DataStax developers run a series of workshops once per week, basically, and every workshop will be, so if you do a workshop, you can be awarded a nice completion badge. A completion badge that is a verified badge that you can share on the socials and, brag about it. Today's badge is the one about GraphQL, of course, and to get it, you have not only to stay with us and follow the workshop, but also do a little bit of a assignment and submit it to us and then we will review it and give you your badge. So stay tuned and pay attention, because there will be homework at the end for you. Okay, I think we're done with the initial part, and yeah, let's do a bit of interactive questions for you. This is not yet the quiz, but this is to get to know you a bit, to know our audience. So let me give you instructions in the YouTube chat and start the Mentimeter presentation for you. Okay. So please go to menti.com and enter the code you see in the YouTube chat or here as well. You can also use the QR code. So there will be a few questions. Please look at your phone or at your Menti browser tab and not at YouTube, because there is a bit of delay. That's in particular true later for the quiz, of course, where time matters. For now, time does not matter because this is just introductory questions. I see people joining. Come on, you're a lot of people. Join us. Let's give our friends a little more, half a minute or so. So Menti will stay open throughout the workshop, so you can join us later. But of course, if you like swag, as I do, you will probably be interested in joining at least by the end. Oh, I see. Right. Sorry. The full code is not visible. Okay, you see it in the YouTube chat, but of course, I didn't notice. I have to. Sorry, Aaron.
Yeah, it's being blocked by my head.
Sorry for the disturbance. I moved you away a bit so everyone can see the full code, and that's okay. Okay, so
Yep.
you can join even later.
Much better.
But I will. So okay, I bring Aaron back to its place, to his place. Sorry. In the meantime, you might refer to the code on the YouTube chat anyway. Okay, so let's start with a few questions just to know you. Do you have experience with GraphQL? And if so, how much? So I've never heard. I know the concept. I'm a master. Okay, I use it here and there. I guess that means in production or in your own projects. Okay, I see. That's a nice distribution. Lots
of new people. Yeah. Excellent.
Okay, so I've never heard about it, and I just know the concepts. Then that's a good day for you and for everyone actually. But of course, today is a good introduction. You will get exposed to the concepts and get the chance to play with it yourself. Now, more in general, as a developer, what kind of APIs are you working on? GraphQL, RESTful, gRPC, WebSocket, or SOAP web services?
I love the help me by SOAP there. Yeah, that's true. Yeah.
Okay, so
especially because SOAP is a little on the old side.
But still running. Nice. So ancient technologies will never really die. I hear most of banking infrastructure is still running on good old COBOL, right?
Oh, so, yeah. Oh, yeah.
Yeah, new things come about, but old things in technology are harder than you think to disappear. But so, okay. REST, of course, is by large. Okay, so good to see. Okay, thank you. Please do not close Mentimeter. Now I'm going to switch back to my slides, and I'll keep Mentimeter open for later. So, okay, so let's start with the actual content. Database. And most important, well, before starting to speak about database, what is the overall architecture of today's application? Because today's goal is to get to the point of running a full application, a full stack application on top of a GraphQL API. So this is a pretty typical architecture design for an application, right? So you have let's start with the customer. You have your mobile client, or your client connect through a web browser of some kind to a front end. So they will run front end code. But this front end, let's say a React application or some HTML plus JavaScript, whatever, it will speak to a backend, which is not running on your customer device, of course. It will run somewhere in a server, for example. and this will in turn speak to a database where, so the database is somewhere else usually, and it provides persistence of data and yeah, a layer to store data and retrieve it later, basically. So that's what a database does, right? Okay, so
right.
there is something weird in this picture, which is not always the case. So you see there is a small block on the right-hand side in front of the database proper, which is called API. And you will see why in a second. But anyway, what we call the application is the two blocks called front-end and back-end. That's what you work on when you write a full-stack application, right? So your database is there, ready to use, and that's the end of the story. Now, let's look a bit more about the technologies and the why of this funny-looking API block. So let's look a bit at these technologies. Let's start from the database layer. So there is a database, which happens to be, well, I would say Apache Cassandra, which is a NoSQL database, and we will tell you more about it later. This is not exactly Apache Cassandra, but it is a product that wraps Apache Cassandra. It is built on it, but it offers more to access it and more around that, namely this API block. So this API block is a data layer working on top of this Cassandra, and it provides a way to access the data stored in the Cassandra database through GraphQL. And you don't have to write this layer yourself. It is there, ready for you to use today. This layer is called Stargate, and it has not only GraphQL, it is much more. We have a slide on that later. But anyway, this database part is ready there for you to use, ready. Now, let's look at the application. The application will communicate to the database, and you see these pink arrows are, let's say, the GraphQL request going on, but let's look at a bit more in detail. We have a front end that's going to be written, that's going to run a React application, so standard React JavaScript node code. And this front end will be what runs on the customer, on client browser. And this application will be issuing GraphQL request to the API. That's not exactly true, but you will see later why it is not exactly true. Let's say for now, the front end issues request to the GraphQL API on the database. And that would be the end of it, but we want to show as much as possible today. So we have a sort of two-faced Janus God kind of thing, because the front end will also issue requests to another totally separate GraphQL server. Of course, that's just a weird architecture if you want, but that's because today we want to show you as much as possible. The second set of requests go to this backend part that you see in the middle of the screen. This is, as opposed to the other GraphQL API, the one in the Cassandra database layer, this is just an application that is going to run. We are going to run it today locally, and it's going to expose a wholly separate GraphQL API, GraphQL server, which will be queried at the same time by the same front-end application. So this is, of course, not something you have to do every time you write a GraphQL-based application, but we want to show two different, totally decoupled ways to work. And in particular, in the second case, the local backend application, the local backend GraphQL server, this is the way we show you how to create your own GraphQL API, because that's not only, so today is not only about client, but also how to create your GraphQL API. Okay, so,
just to, sorry, Stefano, just to address some questions in the chat that I did answer about, hey, is Stargate, a GraphQL API for Cassandra, or does Stargate come with Astra? The answer to those questions are, well, yes. you actually, do get Stargate as a part of the, the Astra platform. But then also, Stargate is like DataStax' open source data API, essentially, that does offer things like, in addition to CQL, you can also use GraphQL, REST, gRPC, among other things. And you can even extend it out to other databases as well if you want.
Yeah.
So
great. Thank you. Okay. So Just to have an idea what's coming later in your hands-on practice, today's application is going to have this appearance. On the left, you see actually what we will see on the browser, what the application looks like, and it's a very simple React application, single page. It has just 4 different blocks which are supposed to load lists of, well, shows, genres, shows again, and genres again. So this is inspired by a sort of Netflix thing. So we are speaking about shows grouped into genres, but this is just by way of example. The point is that there will be 4 different blocks, 4 different components, each one devoted to loading a different kind of item. And the first 2 of them will load from this locally running GraphQL server that you're going to run along with your client. And the other 2 are going to query the GraphQL API in Stargate, as Aaron just remarked. In this second case, the GraphQL API are sitting on top of the database itself, and they will in turn query corresponding tables in the database. You see here the name of the tables and everything, but now I'm not going to go too much in detail here, but I remind you that we have slides in the GitHub repository. Let me start by dropping the link to the GitHub repository in the chat. You will later be able to go and look at the slides. But even our README, as Aaron will show you in a little while, even the README on the GitHub repo is pretty detailed, and it contains enough information for you to go and do everything by yourself in case you prefer to do that later. Okay, so we've been speaking a bit about database, and let's have a closer look at that. Today, I mentioned already that we're going to use Apache Cassandra. Apache Cassandra is a NoSQL distributed database, not based on the notion of a master and secondary nodes. It's a distributed, so it's many machines, many servers, and every one of them has the same power. So every node is created equal. It is a database that is made to handle big data, and we are speaking of petabytes and more. It is very fast at writing and reading as well. It is able to scale linearly. So if you want double throughput, you should be able to do that with double the number of nodes, nothing more. It is designed to offer high availability, basically 100% availability if you configure it correctly. It is able to self-heal in many cases. It automates many of the operations tasks. And what's very cool, it is the database designed to be distributed geographically over the world. So you can have a single database spread over several continents, and it is able to cope with that. That's where most of the highest availability comes from, by the way. Not only you can have a database a bit in Japan, hi Cedric, and a bit in the US and so on, but you can also have your database spread across different providers. You can have on-premise, GCP, AWS, whatever, all forming a single database, which is a kind of strength against vendor lock-in of some kind. And speaking of vendor lock-in, the last cherry on the cake is that Cassandra is distributed with the Apache license, which means that it will never be made into a closed source product. So you can have this kind of guarantee. And Apache, of course, you know that because they are behind most of the most popular software products of today, from Spark to the Apache web server, or Arrow, Avro, Flink, Pulsar, Kafka, the drill.
Pinot, that's another one. Yeah, Pinot's Pulsar.
Yeah. Okay, so that's about Cassandra. And now, as I mentioned, Cassandra was taken and wrapped as a product called AstraDB by DataStax. That is a database in the cloud, serverless database in the cloud, ready for you. So if you don't want to, handle with operations, provisioning your server, installing, and if you don't want to do all of these things, but you just want to use your database, you can go to Astra, you create your database. There is a pretty generous free tier. You just create your database and you start using it for free in a couple of minutes. No operations needed. Not only that, but you also have several ways to access it besides the standard Cassandra native protocol, which is CQL. You have GraphQL, which is what you are going to see today. You have document, think like schemaless JSON-based data access, REST, gRPC, and whatnot. This is just part of, and okay, the other important thing is that this is serverless. So it will not run, it will scale automatically as needed, which means that it will also scale to 0 if you don't use it, which is why it is cost effective in a competitive way. But okay, today we are going to stay well within the free tier. And even if you start using it seriously and running your own small scale production application and database, you're probably going to stay within the free tier as well. So that's a pretty high limit for the free tier.
Yep, yeah, that's a good call out, Stefano. That we do give a pretty generous amount of resources in the free tier. So yeah, and unless you're doing something that's super high throughput or super high storage, you'll probably stay on the free tier.
Maybe forever, unless. But if you grow to need something more, then probably you will have other happy problems of scaling. Anyway, so now it's time for you to start the hands-on, and to do that, I will soon give it to Aaron to start. Now, what you're going to do is you're going to go to a GitHub repo where we have all of today's practice packed, and I'm going to give, okay, the link is in the chat already, but better to have it again. So you will start from the GitHub repo, and you will start by going to ASTRA-DB website, create your free account, and create your database. And also the token, but more on that in a second. And I think it's time to go to the practice. So hands-on. Aaron, I'm going to switch to your screen.
Okay. Excellent. Well, for those of you who have followed the link to the GitHub repo, this is where you'll end up. This github.com DataStax Devs workshop intro to GraphQL. And then you can obviously you can tell from the great big GraphQL logo here that you're in the right place. But just for this little hands-on section, we're just going to get our database created. So if you scroll down to step number 1 here, you can see that we have this create ASTRA-DB button here. And really, if you just right-click that, and you can open that up in a new tab or a new window. ASTRA-DB will allow you to utilize single sign-on or single sign-up in case you haven't done that with either Google or your GitHub account. I'll go ahead and keep mine on Google here. And this is taking a little bit. Oh, there we go. Okay. All right. So Stefano, you want me to use
please, you should switch to the shared org we use for workshops. So that should be
it should be this one, right?
Blank slate, ready to start.
Yeah, so we do have a database out here called Workshops, but it is hibernated.
I thought I deleted it,
Huh.
Pretty sure.
Well, I can go ahead and do that. You were talking about DataStax Devs Workshops, right? I know we also have a DataStax Devs, but I think that's old.
Oh,
right?
That's pretty strange. I was sure I deleted it. Oh.
Well, let me give that a shot here once. Yeah, Workshops, and let's terminate that. All right. So maybe let's go back to home here. Okay, that's busy terminating. But we can at least start the process of creating a new one here. So
really strange.
We have in our new UI, we actually have a button right on the front here for create a database, which will be very helpful. All right. So just to verify, if you watch, I'll jump back to the README here, and you can see we've got it clearly laid out that, you know, sometimes it matters what you name the database, and in this case, we do want it named workshops. But then you'll also create a key space inside of it at that database creation time. And a key space is really just a way to like kind of logically group your tables and some of your data together. And we're going to call that key space intro GraphQL. Nice and simple, just like that. So if I go back here, I should be able to type workshops in there. And then I should be able to go intro GraphQL, just like that. Now you notice I'm currently on the free plan. To continue along in the free plan, make sure that you're on Google and you know, try to pick an area or an AZ near you. So in my case, I'm in North America, so I'll click there. And it looks like the only free one is US East 1 in Moncks Corner, South Carolina. So I'll click that as well. And then I'll create my database. And if it got rid of the old one, okay, it should let me do this.
It will let you create even a database with the same name because, yeah.
Oh, yeah, because it has a different ID.
The ID is
right?
unique, but the name is just a shorthand. In case of duplicate names, you will just have to pay attention to the ID, but no big deal.
Yep. Important to note that ASTRA will create a default token for you. But it's important to remember that that's not going to have enough permissions for what Stefano and I are going to run you through today. So, oh, Cedric says the CLI will complain, though. Yeah, I kind of wondered about that, actually. So, you know, you could save off this token, but I would say don't worry about it because we're going to create a different one. Actually, let me go look. Is that right now? Oh, that is right now, isn't it? Creating the token? Yeah, I suppose we probably want to do that before we launch. Once the database is
created, you can go ahead and create the token and store it somewhere. Yeah. So, okay.
So
we should maybe wait a little time for everyone to get to this point. So please, can you give me a thumbs up if you managed to create your database? I put the name of the database and key space in the chat. So you go ahead, create your database. There is a name for the database, for the key space, and then you just, okay, finishing up, that's great. That means you created it and it's just been provisioned for you by the magic of AstraDB. Great, even active already, that's awesome. Yes.
Good,
okay,
good,
so
good.
you can actually disregard this token that is being created now with the database because now we are going to go ahead and create it, a more powerful one for usage of today. Okay. See a lot of thumbs up.
So, I mean, we could hit this big blue go to database button. It'll kind of take you here. But what I believe what you'll want is to actually go, oh, is it home and then databases? Yeah, home and then databases. And here we go. We have generate a token. So I'm going to do that again slower. Because you know, once you're on that go to database part, for whatever reason those three vertical buttons don't or vertical dots don't have that option on it. But if I go back home and I say workshops or my database here, yeah, I just have details. That's right. I think, yeah, I have to go through it for the database button over here. Yeah. To be able to generate a token.
Yeah.
All right. So did everybody see that in the new UI? It's this databases button in the left nav over here, and then you should see your workshops database listed, and then you have those three vertical dots, and you can say generate a token. Now, for our token, we have to give it a specific role, and in this case, in order to create things that we need for the workshop, we're going to need it to be a database administrator role. So go ahead and click that. And then, yeah, that's pretty much it. You can just say generate token when you're done. What that'll do is it'll give you this little window that says, hey, your token has been generated. You have buttons here to copy the client ID, secret, and token. But it's probably probably just easier to hit this download token details. You notice if I do that, it creates a generated token CSV file, puts that in my downloads folder. And also, I'll just go ahead and hit this copy button here too, just to make sure that I've got it in my clipboard and it's ready for use. So I think that's it.
Yeah.
Yeah. If everybody could give us a thumbs up and let us know how you're doing on generating the token.
Yeah. Of course, that's yeah.
We can.
Yeah, that's a very important point. You should make sure you have your token ready because we'll need it later to authenticate with the database. And we are speaking of the token created with the role database administrator. So Venkat, use default one.
That's right.
As long as you chose the role database administrator, you're okay.
No, you shouldn't need the client ID in the clipboard. I think this one you can get away with just the token.
Need the token, the one started with ASTRA CS : and so on. But it's good practice to just download or save the 3 strings because the point is that different usages of your database will require different strings of those 3. Okay, it's only showing details.
Reissue is showing details options.
Oh, I see the point.
If I remember right,
you saw earlier.
Yeah, because if you go home and then click on your database, details is all you get. But if you go databases from the left nav, then you should have that 3-dot option of generate a token.
So Oscar asks if there is a dark mode for the AstraDB UI. I'm actually not sure that there might be.
Yeah, I don't know.
If not, I will make sure to forward your remark. That might be a good thing to do indeed. So let me take a note.
I was going to say too. It looks like my name is covering it up,
right.
but, or my bubble. But in this lower left corner here, you can click on your profile, and you can actually disable the new UI. So if that's easier for you to find things, see if I go ahead and disable that, it should pop me right back here. And then if I hit those 3 dots, see, I do have an option right away to generate a token also. So if you're having trouble, that might be a way to, a way to get past that. All right, but I'm going to go back and make sure that new UI is enabled for me. All right. Well, Stefano, I think that's everything then. I'm seeing a lot of thumbs up.
If you all have your database and your DB admin token ready, then we can switch back to a bit more GraphQL stuff and then get ready to the second part of the practice. So, okay, let's go. You see, I switch between big and small faces for us to make sure during the demo part we don't cover valuable real estate on screen, because there might be something important everywhere, as we just noticed with the lower left menu. So, okay, so it worked. Reissue managed to get the token. Great, well done. Okay, so let's go a bit into the GraphQL topic itself. What is GraphQL? GraphQL, maybe before starting, I should say that GraphQL and graph databases are not entirely, actually, they don't have much to do with each other. I saw a discussion in the chat about that. Thank you, Cedric, for picking that question and expanding a bit on it. So GraphQL, let's get this clear from the start. GraphQL has nothing to do in particular with graph databases. So this is a bit of a confusion that in a sense was fueled by Neo4j language, maybe.
Yeah, they joined the GraphQL ANSI standards committee or something like that. Yeah, and I know that. Yeah, I remember when that happened, that confused a lot of people. So
get this clear and then we can start. What is GraphQL? Again, so GraphQL is an API query language, is an API paradigm to gets data from an API. So it's a language to do requests and gets data back, or to issue operations such as writing to a database and get data back. It's not only that. So it is an API query language and also a server-side runtime. So it's a set of specification on how an API server offering a GraphQL endpoint should be structured and should work. And the main spirit of GraphQL, especially if you compare it against REST, typical REST APIs, is the idea that you should give customer exactly nothing more than the data they need. That's the main point, I would say. And the second point is that you should make it unnecessary for the client to ask many different parts of the full thing they need. So you should make it possible to get everything with a single request. We will see later how this is accomplished, but before that, just a bit of history. GraphQL is 10 years old today, this year. 10 years old. It was created with by Facebook, originally used for as an internal tool. Then a few years later, after honing the tool a bit, it was popularized and open sourced at some point. But the real boost in popularity came when GitHub announced to have adopted it for public-facing APIs. And well, since then, many more other companies started using that here and there, and then more and more. And today we know that it has quite some popularity. Okay, so this is very basic introduction. Let's look a bit at some code and how it works. Okay, so I want to say something as a starting point. In GraphQL, in a GraphQL API, everything starts with a schema. So the first thing that happens is defining a schema. That's a way to say that GraphQL is a strongly typed kind of approach. It is, in a sense, the very opposite of schema-less approaches. Actually, there is a whole language defining what kind of objects and what kind of data types are there. A whole language called GraphQL SDL, Schema Definition Language, that is actually a fully fledged declarative language, including interfaces, inheritance, reuse of code snippets. And as you see here in this lower code block example, you can have, there are data types, there are lists, there are compulsory or optional arguments, and so on. So you see, you define types and start defining how and where they enter and in which relation with each other. But I'm getting a bit ahead of myself. So let's say it all starts with a schema. The schema defines what data types are there to be queried in their GORI details, field by field, basically. And then once the schema is there, the queries that are going to be run are built in a similar way to a JSON. Let's say a JSON without commas, I would say. So, okay, that's a bit kidding, but the point is that when you run a query to a GraphQL server, you specify exactly the fields you need, as you see here in this upper block example. And this you do with a JSON-looking kind of syntax that defines the full tree of items that you want back from your query. Of course, that allows for arbitrary nesting of fields and objects. We will see that in a second, but that's more or less the gist. Okay, so as I mentioned, GraphQL protocol, GraphQL query specification allow to specify exactly the fields you need. So if you compare this upper block with the previous one, you see now I'm asking for the title of all shows. In the previous block, I was asking for title and release year. And that's just the possibility of defining exactly the fields you need is at the heart of GraphQL. So this is something that comes with the specification. So raise your hand if you never had to implement an ad hoc projection field in your REST endpoint. We've all been doing that probably. At some point, you need a special field that specify which columns you want back from your table query, and then maybe those get passed to the SQL query. So why? So that's, in this case of GraphQL, this is really part of the base specification of your API, which is cool, right? So think about an environment where bandwidth is important. You want to get back just the data you need because you are on a mobile network with low bandwidth, whatever, and that really comes as a helpful thing, right? Not only that, but the other good point, the other very cool point is that if the schema allows for it, you can ask in a single query for aggregation, basically resolving joins if you want. So in this second code block, I'm asking for some fields, some properties of shows, one of which is actors. And in the underlying database, probably there are shows on one side and actors on the other side. So in a typical REST setup, there would be two different queries, right? In this case, the complexity is hidden away in the GraphQL server, which handles this complex data fetching. And what the client needs is just to ask for a single object, a list of shows, and in each show, a list of actors, of which I need just the name. And this is exactly intuitively expressed in this GraphQL language you see here, right? So it's really like a JSON without commas, if you want. Okay, so let's go forward. Well, as I mentioned, the schema allows for specifying types. Well, you have to specify types. You see there are some primitive types, integer, float, the usual bunch. And then there is this funny ID object, which is just an object unique identifier kind of variable. And when you define schema, you always provide the data type. And you can see here that you can also use, and you usually do that, you use user-defined types. So you see there is this type show, which is something that I built on using primitive data types. And then there is this type actor, which again has a compulsory string called name and an integer, optional integer called age. And as you see, the actors field in the show data type above is a list of actor items. And this is how you encode relations in your GraphQL schema. And depending on what these objects, on the relations between these objects in the schema, that influences which kind of queries you can ask the server, and they will encode the same relations as you saw in the previous slide. So this is more or less the big point of the GraphQL structure. Okay, so this is a slide stolen from the GraphQL main website, the official website, graphql.org. And again, you can see here there is a slightly more complex schema with a few types, character, planet, species. Now, it's a good time to specify that this special type called query is a keyword, is a reserved keyword that is used to define the entry points in your API query. So every query to GraphQL server should start with the items mentioned in this special type called query. That's just an important point related to this is that think about REST API. You have a bunch of endpoints. You should look them up in somewhere in the documentation. Maybe if you're lucky, there is a Swagger, an OpenAPI compliant way to find out everything about your API. Yes, but maybe not. Anyway, you need to know exactly which endpoint to query for what, for everything. GraphQL is really the opposite again, because a GraphQL server will expose a single endpoint, which is just, let's say, slash, basically, and then whatever query you send to that endpoint. And depending on the shape of the query, as you see here on the left-hand side, you will get whatever you need. Again, that's why the type query with its entry points lists all that you can ask for to the GraphQL API, to this server. So there is a single endpoint. That's pretty fun if you're used to REST, but that's how it works. Now there is a further distinction to be made, which is going to be important later during the practice. There are something called queries, and this is something that you have seen a bit of examples of. And there is also something else, but let's look at queries. Queries, and here you see a slightly more complicated example where the query also has a parameter. So I'm asking for shows, but I want to filter them by title. Okay, I can do that as long as the schema specifies that I can, because you see below that there is how this presence of the parameter is encoded in the schema. It all starts with the schema, don't forget. So queries are supposed to be just asking for stuff. Queries are to get data back from the server and nothing else. And okay, queries are where you can specify which fields you need, which subfields in the sense of relations, as you saw before, actors within shows. And every query must be described in the schema. Okay. And this is more or less, this is another example of query. So I'm asking for name, height, and mass of this hero, and I will get back exactly what I need. So that there is a one-to-one relation between the shape of the query and the shape of the result, which is cool, which is nice, easy to debug, easy to maintain, and a few other advantages.
Oh, we're missing Luke Skywalker's home planet on that one.
Yes, that was not asked for, you know? Yes, because someone took out that from the query and the server is not going to give it to us. That's exactly how it works.
Yep.
Okay, so there are not only queries. Of course, a full API should also give you the possibility to insert some data or anyway execute some active actions that change the state on the server. Usually it's writing data, but it might be something different. And these are called mutations. Mutations, something changes, so it makes sense, right? So these are not queries, and they have a slightly different syntax. Again, mutations are going to be defined in the schema, otherwise they don't work. But, well, the syntax is not that different. Basically, they are a way to invoke some action. Like in this case, you want to insert a new show, and you have to provide fields, title, blurb, etc. Again, if you look at it, there are nested fields here as well, which is cool, and the server will take care of that. So you specify the argument, let's say in this case, the new show to write, and beside that, you also, in the same mutation, you also specify what to get back once the operation completes. So in a single sweep, you write data and you get back updated fields, which is sometimes very cool. Again, think about constrained environments, mobile application. You want to have as little requests as possible, maybe with also not so much, so many bytes of data flowing through. So that's pretty much an advantage, less overhead. So these are mutations, and these are not sample. Oh, by the way, this is wrong on the slide. It should be mutation. Let me take a note for next time.
Oh, right.
Sorry. But you get the point. This is a mutation, and it's not a query. Okay, so this is more or less all there was to say about starting with GraphQL. Let's just summarize with a bit of objective analysis, the pros and cons of GraphQL. Well, there are many pros. GraphQL, one thing that I didn't say is that usually a GraphQL server exposes its schema. So it's supposed to expose its whole schema, which means that it's very easy to, in terms of discoverability, there is a single endpoint. Once you know that one URL, that one endpoint, you can get the schema, you can do introspection, you can basically imagine a client application, a client tool that helps you with auto-completion, that helps you build queries, and you know exactly what you can ask for, and a lot of nice things. This might be also a security issue in some cases, because it might, expose too much, maybe make your API reachable by some kind of DDoS sort of attacks, such as when you ask for something that has an infinite loop of nesting or whatever. Of course, this is up to you to make sure this doesn't happen. And this is already a bit of a con in a sense, unless you rate limit it. So I'm jumping back and forth in this list, but I'll try to touch every point. So something we said already is that it has a pretty well-defined language for fetching data, which allows for aggregations, relations. You can customize exactly what fields you want back. Then there is the point of versioning. Ideally, in the whole philosophy of GraphQL, you should never have to work with v1, v2 API prefixes, basically. You should not version it as a monolithic jumping from v1 to v2. Sorry, Aaron?
Oh, no, I was just saying like you would for
That's
REST,
pretty typical, right? Ideally, since the GraphQL query always specifies exactly what you want to get, if you add a new field, you will be sure no existing application would break, because they will just get back exactly the same fields as before. So you can keep adding fields. Taking fields out, of course, is a different thing, but that's another story. And another good thing is that, yes, GraphQL is its own thing, but it's still based on HTTP and JSON over HTTP at that, because the return item usually, so the returns from the query, the return payload is a JSON, so easy to parse and pretty universal. Now, as I mentioned, the fact of having a single endpoint is also, in a sense, might also be cumbersome in some cases, exactly because you might still have some need for V1, V2 kind of versioning, and then you will have to run two GraphQL servers probably at once. It might be cumbersome from the monitoring part, from the monitoring point of view for, well, also that because the tooling might still be a bit younger than REST in most cases, even though they are quick evolving. The implementation is complex. So GraphQL specification takes many more lines of code. If you think of the parser for GraphQL queries, it is like maybe 5 or 6 times longer than for the typical REST API parsers. And that means that well, there might be still some, in the typical implementation, there might be some security loopholes that, so there is more room for possible security problems to be discovered. That depends on the implementation, of course. And also tooling-wise, well, probably REST stuff has a bit stronger set of tools available, even though you will see today there are some pretty cool tools for working with GraphQL interactively. Another point is that, yes, I mentioned that relations get resolved on server side. The client never has to deal with querying one table and then querying the other table and joining the results and everything. That's very cool and good. But of course, if you hide this kind of a complexity, you might end up with very bad performance on the database side, because you might have N+1 problems or similar just hidden away from the client. And that's the point. So to help with that, and also against this kind of DDoS attacks, potential attacks, you probably want to implement some kind of rate limiting to make sure you're not falling into this rabbit hole of performance. And then there is the issue of caching, which is not always trivial, because sometimes a single GraphQL query might need the same piece of data several times, and in a naive implementation that would mean as many queries to the database, which is suboptimal. So you might have to find, so usually frameworks for GraphQL have their own caching logic, which is pretty sophisticated and tries to strike a compromise between stale data and good performance, basically. So, okay, so some of the last points in blue we mentioned already. Something we should just mention is that modern GraphQL specification allows also for a neat way to write an API that just joins between different sources, different GraphQL sources, join together in what is called federations. And I think that's more or less it. Let's move to the tooling part, because that's something you will see soon in the practice. So I mentioned pretty advanced tools to play with GraphQL. So there are interactive interfaces to just play with queries, execute them, and see the results live. That's, of course, a valuable tool when you are developing. And today it will be a very useful tool to get some familiarity with GraphQL. So this is something called GraphQL, GraphQL. I think it's pronounced graphical for fun. Yeah,
that's catchy.
So it looks like it is a bit the GraphQL counterpart of the Swagger interfaces that let you play with endpoints and start doing requests in the web interface itself. So basically, well, this will come for free with the very application you are about to run, the server application, which exposes also this interface. And it is, you see, there are two panels. On the left one, you write your queries. Then there is a nice play button to execute them against the server. And then on the right-hand side, you see the result. And as you see, the result is an actual fully JSON compliant string. So it is really a JSON, easy. Then again, on the third panel, you see also the schema is exposed, so your client is able to help you navigate the full schema available in this server. So this is one of the tools, and something very similar is called GraphQL Playground, based on the same idea. This is what you will use to play with ASTRA-DB GraphQL interface. So this is offered along with the ASTRA-DB Stargate GraphQL interface, and it looks very similar to the previous one. So it is a panel on the left where you write your query, then there is a big play button in the middle, you hit play, and if the query works, you will see the result on the right-hand side. That's it. While we are at it, and we will have to stress it a few times because that is a bit tricky, you see there are two different tabs here. One is called GraphQL Schema and the other is called GraphQL. Well, Aaron will tell you more about this, but just one thing, one is for managing the schema, so create tables and the like, and the second one is to work with data, so reading and writing. These are two conceptually separate blocks, if you want to know. My point is that when we will then speak about playground tabs, these are the tabs we mean, and not, of course, your browser tabs. We don't care about your browser tabs. These are the tabs in the playground application. And when we say switch tabs, this is what we mean. Another important point is here at the bottom, you see there is a string. This is where you will be required to copy paste your Astra CS token, because this application, as any application, will need to authenticate with the GraphQL server to run queries. And it's a specific header. Aaron will show that later. It's a specific header. You have to paste here your token for the queries to work. Okay. So in the next hands-on, you will do two very important things. You will run your GraphQL server. You remember the backend running locally, and query it with GraphQL. And as a separate thing, you will go to the GraphQL in ASTRA-DB, and you will run the playground to execute queries. So you will run queries manually with the play button in two different tools, interactive tools to experiment, graphical and then the playground. To do that, you will be using Gitpod. You will see Gitpod living in your browser in a second. So this is just a reference picture. It looks a bit like VS Code. Indeed, it is very much VS Code in the browser. I think Aaron will show that to you. And yeah, this picture is there just because it is also in the README, and it might be useful as a reference map to those unfamiliar with Gitpod. So there are two consoles, an editor on the top, and on the left-hand side, a file explorer to open files and look at the directory tree. Okay, so this is redundant because I just want to stress that the browser tabs are not the tabs in the GraphQL playground. Sorry to stress this, but this is usually where people get a bit tripped. So that's better to reiterate. And now I think it's time for you to start the second part of the practice. So launching Gitpod and then running a few queries. To you, Aaron.
Hey, Stefano. Oh yeah. Just real quick while we transfer over to me. There was a question in the chat about like, can I implement like custom sorting in a GraphQL query?
Yes.
Do you know the answer?
Yes.
I'm pretty sure you can.
You mean like asking to ascending or descending sorted by this or that field? This is done in the schema. Right. At the schema level, this is one of the parameters of your query. So you remember the schema makes it. So in the schema, you define what parameters a query can accept. There might be a field called sorted by, for example. And if you do that, then the query will be able to accept the parameters. And of course, it's up to you in writing the server code. When you retrieve data from whatever database you have or anywhere, a CSV file, whatever, you will sort them. You will sort them by whatever is passed as an argument and give them back to the response. So GraphQL-wise, you just add a parameter to your query, and then it's your code that will be understanding this parameter and act accordingly. So that's not out of the box, of course, because that's your logic. But yes.
Right. Well, thank you, Stefano. So hey, following our step here for number 3, we have this open in GitPod button. So I'm going to right-click that and say, hey, open that in a new tab. Then I'll click over to that. And you'll see that that GitPod is essentially like pulling its image down. It may ask you to authenticate with your GitHub account. It didn't ask me because I just like tried it out again this morning to make sure it worked. So my my creds hadn't expired yet. But you know, once you get past that, once you authorize it, this is kind of what you'll see. You'll notice too the difference in that you know, the slide that Stefano showed, you know, where it had an example of what GitPod looks like was in like dark mode. Actually, this is not dark mode. So is that light mode? I think that's the antithesis there. But you know, if you did everything right here, you should see these terminal windows coming up. They'll both like be processing some things. You know, you'll see the README that we're on kind of come up here in one of the browser windows as well. You'll have this Get Started tab that you don't really need. You know, another point too, further to add to the tabs conundrum that that Stefano was talking about, is that you'll also have tabs inside of GitPod here. So that's, you know, important to be just cognizant of that as well. But let's see, if I scroll down here, all right, this should. All right, so I see our demo application is indeed running. That's good. And then over here, we're still pulling some things down. But what you can see is that up here in my URL bar, I have a pop-up notification. This is where GitPod is trying to open another browser tab. So I'm going to click on that, and I'm going to allow GitPod to do that. And then I'll actually like click on this this URL here as well, and that should bring it up in a new tab. And let me kind of organize my tabs a little bit here. But this is essentially that GraphQL that Stefano was talking about, where we'll actually end up doing, you know, maybe like the first part of our exercises here. So of course, you know, we want to mention that right now we haven't done anything with the database. So we're not. So we've gone ahead and created our AstraDB instance, but we haven't tied up the connection yet. So really what we're looking at here is just you know, kind of a way to mock up some of that data, just to give you an example of what we're going to be doing. So if I jump back over to GitPod here, you can see that it wants me that the exercises are, okay, we're going to plug these queries. Actually, why don't I shorten these up a little bit? But there are 4 queries here: just title, with release year, get one show, and shows and genres. If you go over on the side, oh, it doesn't come up. Oh, GitPod doesn't show that. Well, if you're looking at GitHub specifically in the README, you'll notice that we have these 4 queries defined here, and we have a copy button. So you can just go right over to the side, and I'm just going to copy that, and then go back to my GraphQL window, and I'm going to paste that right on the end there, like that. And I'm going to do the same, the same with the other 3 as well. And back over here, get one show. And then the last one is shows and genres. All right. Okay. So now that I have the 4 of these, you know, you can mess around with these a little bit. If you hit the red execute query or play button kind of in the middle here, you'll see that you get a drop down of which of the 4 queries you pasted in there that you want to run. So I could go ahead and say just title, and I get a list of, the titles back of shows like, Stranger Things, Ozark, The Crown, Dead to Me, and Orange is the New Black. I can go click that again and say, hey, give me those with release year. And you can see I have essentially the same data coming back, but now in addition to the title, you also see what year it came out with. Get one show. We have Ozark kind of hard coded in there just as an example, but you can click that, and of course, yep, you get Ozark back with its release year. And then shows and genres is the last one. That one will actually bring back data that's both in the show's data source as well as the genre's data source. So in addition to all the shows that we were talking about before, you also see, hey, we have genres of action, anime, award-winning, children and family, and comedies. So yeah, just a different way that you can kind of interface with this through GraphQL.
Yeah.
that is kind of a catchy name.
Yeah.
Yeah. All right. So if we jump back to Gitpod here, let's see here. We have, oh yeah. So the next thing we can do is to go back to let's see here. Yeah, back into ASTRA. That's the next part of this actually. So let me sign back in.
Yeah, so maybe in the meantime, I'll just say one thing. What you just run on GraphQL is query against the server running locally in Gitpod. So that we set up Gitpod so that it starts again. It starts automatically when the Gitpod initializes. And you will see that you have seen that running. It's a Spring Boot application. You have seen it on the right-hand terminal running, maybe. While it runs, it also exposes this GraphQL interface. But the point is that this is not reading from DB yet. It is just reading from hard-coded lists in the code. If you look in the README or directly in the Java application, you will find that there is a lot of things that resonates with what we just saw. So there is a resource defining the schema, and there are Java modules basically defining how to fetch the data. In this case, they just read a hard-coded list, but conceptually they are just retrieving a list of genres, a list of shows. And in particular, the filter by title query has the parameter that matches in the schema and in the Java code, because it is all automatically wired. I hope that we will have time later to go a bit more and look at the code, but at least I wanted to give you a tip on where to look for more.
No, good call out. Good call out. Anyway, so let's get back to ASTRA. What I'll do is maybe increase my font size a little bit here. I'll go ahead and click on my workshops database. And then as I do that, you'll notice that I get another set of navigation tabs up on top here. I'm going to click the Connect tab up here. And the one that shows up kind of by default here is the GraphQL API. And down here in this step number 2, create a table, you can see there's a link to the GraphQL playground. So I'm going to go ahead and click on that. Now this is actually going to open up the GraphQL playground inside of Stargate. That's a part of my my Astra instance. So now just to kind of highlight, this is what Stefano was talking about. You can see at the top here we have my browser tabs, but then here inside the GraphQL playground we have 2 tabs: GraphQL Schema and then GraphQL. And that's one is for using that GraphQL Schema definition language, and the other one is for actually running mutations and queries. So the first thing we're going to do here is, remember we had you grab a different token. We're going to make sure that token ends up in HTTP headers. Now, you'll notice when I expand that, it has this parameter down here, if you can see it, called x-cassandra-token, and it has a value in there already. Well, that actually is the default one that gets created, but of course it doesn't have the permissions we need to create new
Aaron,
underlying
sorry.
tables. So
maybe you might show once more how to get to the playground. Just very quickly. I mean, I
sure.
pasted a link to the instructions in the chat. There are instructions with a nice picture on YouTube, on the YouTube chat. And actually, we have pictures for both the old and new UI. But there are, since there are a bit of clicks to be made around the interface, maybe you can quickly go through it again. Sorry for interrupting, but before.
Yeah, no, it's okay. You know what I missed? I missed the drop down arrow here for the
in this
new
case,
UI.
It's almost the same, by the way. So this is a part of the UI that was not changed drastically. So that's
okay. Yeah. But if you look here, I mentioned inside of ASTRA here, going to where my database is and clicking on it, and I get these tabs at the top here. That connect tab is the one you want. If you look in the GitHub repo, you can kind of see that we have that connect tab highlighted, APIs, and then GraphQL kind of shows up as the default. And then down here in the number 5, you can see that create table step has that GraphQL playground link. Now, if you're on the new UI, which I was, you can hit this little arrow here, and it'll kind of show you the same thing, but just with the new UI. And yeah, Stefano, you're right. It's really not a whole lot different, but yeah, it's the same principle of find that connect tab in the navigation. Make sure you're on the APIs method. Then look for the GraphQL API, and then down to this create table step is where you'll get your link for the GraphQL playground.
Okay, great. Thank you.
All right.
So Giant found the way. So
yeah, I know. It can be a little confusing. Let's let me open this up again. All right. So again, go down to the bottom here. You're going to default into this GraphQL Schema tab inside the playground. And then you'll want to open up that HTTP headers. And in here, oh, nope. I thought I had my token in my clipboard.
I'll move you up a bit
just
to show the header. Oh, thank you, Jeremy.
Oh, okay.
Okay, great. We spent some time trying to make sure the repo is able to explain itself, even for those who stumble upon it without the live, and they are just able to play and learn by themselves by reading it. So thank you for this.
All right, so I've gone ahead and pasted my token in there, and you'll recognize the token because it's the part that starts with that ASTRA CS : text. So it's prefixed by that. So as long as you grab that and then make sure that that's in here and that it's encapsulated in double quotes, you should be okay. All right, so the first thing we're going to do, once everybody gets their token pasted in there, is we're going to create a new table out there. And if you, again, if I bounce back to the README, and yeah, we go to step 5C here, you can see we kind of have this table schema laid out here. So we have, this will be just a quick little reference list. Somebody had asked a question earlier about sort order. You can see that, hey, here we do have order ascending. That actually is the default order that it gets stored in on disk, if you've worked with Cassandra long enough. But anyway, I will go ahead and copy that. And this is going to go into my intro GraphQL Key Space, and it's going to create that reference list table underneath. So if I go back to that GraphQL playground, and I just paste that all in here, the next thing I'm going to do is go ahead and hit this play button right here. execute it, and if it worked, I should get back the name of the table and true. So with any luck, that's what you'll get as well.
Yeah.
I don't see any oh, I even see a couple of thumbs up. Okay, that's good. That's good.
Okay. So this is the table creation, and that's done, of course, in the GraphQL Schema playground tab. Again, tabs.
Right.
And
right.
if you will notice, it's not a query, but it's a mutation because it's an action to be executed on the server side. So it's, of course, a mutation. It changes things on the server. Well.
All right. Let's see. Okay. So no issues on that I'm seeing in the chat. That's good. So let's go ahead and insert something into that table. So if I go back to the README, let's see here. All right, so we got inserting data using the GraphQL playground. The first thing we have to do is to modify our URL here. Because what we want to do is make sure that we're going into our key space of intro GraphQL. Oh, I did not want to do that. But if I go back over to my playground here, you'll see when I change tabs that it has the system key space on the end here. So I'm going to get rid of that and then paste in the name of my key space. Then what we're going to do, oh yeah, we also have to drop our token into the header on the GraphQL tab as well. So just quick to call out, but you'll need to put that token in both the GraphQL Schema and GraphQL tab. So yeah, make sure I do that quick. And then tab back over. Come on, hey, there we go. All right. Back here, and then I can look at my header right here. Yep, you can see I do have that default token in there. And I will just paste my new one. There we go. All right. So the next step is going to be running this insert genres mutation here. So what that's going to do, before when we looked at the GraphQL, that was just the, kind of pulling against that static data. You could see that we had our genres up like action, anime, award-winning, et cetera, et cetera. But we're going to create that in our database. That way we can pull it out and work with that as well. And actually, we have a whole lot more genres in here than we had hard-coded before. So let me just click that copy icon. And in the GraphQL tab, I should be able to go ahead and just paste that in. And I should be able to run this. And with any luck, oh, look at that. It looks like it worked. Outstanding.
Okay, great. So I see a weird error by Venkat who says showing books, not reference list. This books sounds like an example that we have on our documentation in ASTRA. So maybe you are somewhere else. Did you make sure you followed the steps to open your own playground on your very own actual real database? And that might be...
Yeah, that would be
important. Okay, got it.
I agree. It looks like...
Okay, that was probably just...
Okay.
I know why. Maybe it was just, the connect page has some quick start static text containing queries and responses about books, I guess, if I remember correctly. Okay, so thank you. It's all set. Okay.
Yep. Cool. All right. So hey, moving on, we can retrieve values from the database using that GraphQL playground as well. So we just inserted a whole list of genres in there. Essentially, what this get all genre query is going to do is it's going to pull against that reference list table, and it's going to match on the value of genre. So if I go ahead and just copy that. Stefano, do I need to paste over the mutation,
You
or can
can
I just
paste
put
it
it on
at
the
the
end and
end,
it should
and
ask?
if there are more than one queries or mutation, the play button will have a drop down.
Yeah,
So that's, yeah,
that's what I
it should
thought, but
be.
oh yeah,
Yeah,
look
it
at
should
that.
be.
We get the drop down. Outstanding. So if I say get all genre and
Yeah.
run, you can see that, hey, we have our values from our reference list, um, kind of over here on the right. So yeah, it looks like everything came back there. And I think that's everything. Yeah, I think that's it, because the next steps involve us starting up React inside a Git pod. So I
Yeah,
think we go back to the
this
presentation.
is
Yep.
this is for this part of the hands-on. That was it. So you've been testing GraphQL,
Yep.
sending queries and mutations using both the GraphQL from the locally running GraphQL API and also the GraphQL playground offered by ASTRA, in which you actually used a real database, creating tables, populating it, and reading from it. And this will be basically the very same queries that will be used by the client. But before that, I think we are going to go a bit fast on this backend part and maybe spend a bit more time on the front-end part. How do you hook React applications to GraphQL? And the reason is that the backend is one of many frameworks to create GraphQL servers, GraphQL API applications. While the front end, React, well, it's one of many frameworks, but it's React, so maybe that's a bit more universal kind of thing. But anyway, let's go to the point. So the final goal would be to connect our front end to GraphQL, in particular to the API, exactly as we did with the playground. But before that, let's say you have to build a GraphQL server, a GraphQL API server yourself. So how do you go about it? Now, I'll keep this discussion very general because, as I said, there are many frameworks to do that, and in many languages. You can write a GraphQL server in basically all language under the sun, I guess. Many of them, at least, Python, Java, Node, you name it. So the main one have several different libraries and frameworks to do that. But the general ideas boil down to simple concepts in a sense. And Aaron, there is quite a similarity in creating a GraphQL API, in designing a GraphQL API with how you would go about designing a database schema in Cassandra, because you start by understanding the conceptual data model. So what entities are there, what relations are there, and what attributes they have. And at the same time, you look at the needs of your application and you start thinking of what are the relations that you have to expose in your API. Remember, the relations between items, between different entities in your domain is something that you have to encode in your GraphQL server way more deeply than you would do in REST, because in REST, the responsibility of relations and joins basically would fall on the client. In this case, you're just exposing a tree of relations yourself, you, the server. So that's very important as a starting point. Now, there are two different ways to go. One is you start with a schema. You just design the schema with this schema definition language with types and user-defined types and type specifications and everything. And then you have most frameworks offer this code generation. You end up with ready-made stubs, function drafts to fill with your logic, of course. Still, you have to write your own logic. And that's a bit of a design-first approach. The complementary way, if you like code more than schemas, you write code, you write functions that retrieve data, and you make basically you in most cases you do annotations everywhere, and you make the GraphQL framework aware of what role these data fetchers have in your schema. And then the GraphQL framework will just connect the dots, wire things together for you, thanks to this annotation. Think Spring Boot. That's a very friend with the Spring Boot philosophy. And you end up with a fully working GraphQL API where every data retrieval is connected to the other through this big schema, which is generated for you. Some framework even offer you both ways. In particular, a famous Java framework to do that is DGS. It's Data Domain Graph Service, I think. That's been developed within Netflix, and it's one of the most popular Java ways to create your own GraphQL API. And that's based on annotations, indeed. I don't think we'll have time to go into the code, but in the README of GitHub, you will see what might be the good starting points to see how it works. So this will be built on top of, it works in tandem with Spring Boot. And internally, in a real application, it will use drivers, because what you define essentially are data fetchers that GraphQL framework knows how to connect and to offer client-side, to invoke, to satisfy the client's requirements, requests. But on the other hand, within every data fetcher, you write your own logic. Now, in the application, you will see in this repo, there are just hard-coded lists. But in a real life, you will use drivers, for example, Cassandra drivers, and start querying the database. Now, just a bit of code. How would this work in practice? Well, there are two steps. One is defining types as classes, as Java classes. You see this genre class is a POJO with its standard methods. And this will be mapped automatically to parts of the GraphQL schema by name identity. So the name of the class will have to match and the name in the schema. And on the other half of this slide, you see how you would write a data fetcher. So it's a class that has a method to get, in this case, to get the genres. And thanks to annotations, you see this DGS component tells the DGS framework, this class is going to be part of the data fetching logic. And with this DGS query, you are saying this particular method is going to be the one that will retrieve the data, and please, DGS, use it as fit to satisfy the client request when a request comes. And all the wiring is done for you, and that's pretty much true for every GraphQL framework in every language. All the wiring is done for you, and you see there is also an annotation to specify that this label filter is an input argument. And maybe you remember when you were playing with GraphQL, one of the queries had this as argument, label filter equal oddsarg. That's exactly how it works. It ends up being just Java code. But I think that is what we can afford looking at as far as Java code is concerned. Let's speak of front end, because that's something that you are about to run in a little while. So theoretically, you could just have your React application or your client application issuing requests to the GraphQL API on top of Cassandra, right? Exactly as you did with the playground. So you slap your fetch function code in your Node application, and you have your client able to get movies, get the genres, get the shows, and display them in the browser window. That's all cool and good. But of course, there's a trick here, because if you do that, then okay, this is something I said you can use any library to issue requests, and you could in principle just fetch resources on the GraphQL URL, sending the right request and getting back the right JSON, and everyone is happy ever after. But if you do that, the police is coming for you, because if you want your client code running in your customer browser directly speaking to the GraphQL API, then you have put your personal, very secret token in the hands of everyone. That's really no good. That's why you should not do that, of course. In a production environment, you will never give the token to the client code, right? Because the token, I mean, if I have your DB token, I can do everything with your database. And that's really no bueno, right? That's why we have a different way to go about it. Today we are going to use Netlify. Netlify is, well, a very nice framework that works on the Jamstack architecture, that implements the Jamstack architecture. I don't think we have much time to go in detail, but we have separate resources on Jamstack. You might want to start with a README and maybe read further if you're interested. The main point is that it looks like you're writing a client application and that's it, but secretly, or well, not so secret, but within this client application, there is a thin layer that you write as functions. They are called Netlify functions, and they will be taken separate and not built into the bundled front end, which is then going to run in your client browser, but it will be run on a thin serverless layer in servers around the world, so that the final architecture is the actual client code, which is everything else in your application, will run in the customer's browser. Then there is this thin layer of functions which are not running anywhere in the client. They are running on servers somewhere in the world, like on infrastructure provided by Netlify, for example, and they will be entitled to have the token. And they, in turn, will send a request to GraphQL, to the database, to Stargate GraphQL. So there is a thin layer that acts as an API, a thin API. So you will see the client, the React component, speak to the serverless functions. The serverless function will issue GraphQL requests to the database, to the GraphQL database, as the playground does. And the cool thing is that all secrets are never going to percolate to the client, actual client. The secrets will stay on the serverless functions. Now, Netlify also offers the infrastructure to do that, a CDN to distribute to the client proper, and also a serverless architecture to run your functions without having to worry about provisioning machines. This is not something we are going to run today. We are just going to run Netlify in dev mode, which means everything I just said is simulated in your machine. But the spirit is that once this works, you are going to be able to deploy it on a real Netlify distributed architecture. But if you're interested in how to do that, there is a follow-up to this workshop called Build a Netflix Clone with GraphQL. You can look for it in our YouTube channel. And in that one, the full story up to deploying to Netlify and checking the application runs is done. So if you're interested in this Netlify magic, please go ahead. It's a very cool thing. Okay, so the final result will be like you see now. The front end is actually can be thought of as two completely separate things. A CDN will, okay, today, not a CDN today, but conceptually, a CDN will serve the bundled, compiled client, actual client that goes to the browser, anyone's browser, and runs there. This, in turn, will query the serverless functions, which are running not on the client. So secret-wise, you're safe. And these, in turn, using the secrets, the token, will query GraphQL. And that's more or less how you do that usually. I think I spoke enough, and I let Aaron show that by example, which is always much more effective. So you will start the client, you will see it work, querying the local GraphQL server, the one built with Java and DGS, and then you will also make it possible to speak to the actual database that you just set up. And you will run the very same GraphQL queries that you have been running manually in the playground, but just hidden inside the React code. So, Aaron, I think that's back to you again.
Yeah, let me just scroll down. All right, so I'm inside of GitPod here, and you can see that I have the README up, so I can kind of see what I'm doing, you know, through a lot of these steps. But we're going to start up the React app here. So what we're going to do is we can go to our client terminal, which is you know, this let's see here, this one on the left, and we can actually run this npm install -g netlify CI. Netlify-CLI. All right. So, of course, if you've ever, installed anything with NPM before, this is going to pull down a whole bunch of stuff.
Yeah.
But with any luck, yeah, okay, came back, good. And then we can go ahead and invoke this by
Aaron, that's because we configured GitHub to install almost all dependencies are ready for you secretly. Otherwise, it would be 5 minutes, 2 minutes, 3 minutes. Yeah,
it would be quite a bit. Yeah. Good job there, Stefano. Yeah, saved us some time. All right. So Netlify Dev here is going to, start that React JS application, and you can see it's actually bringing up a like a browser within a browser here, we can see that it's running all of these queries. Now remember, like Stefano said, we're not tied to a database yet. So again, this is data that's been kind of mocked up here. But we have shows coming back, so that's good. We have genres coming back, that's good too. But if we look at like shows by AstraDB here, and reference list, so this is illustrating that we haven't quite tied up our app to the database just yet.
And in particular, the reason is that the Netlify function, the serverless functions, have no knowledge of the secrets, or they don't even know what is the endpoint to ask. Because if you look at the playground URL, your own database ID appears in the URL itself. So they have no clue where to go yet.
Right. Also too, if we have a look at Stefano, I don't know how much time do you want to spend a whole lot of time in the code, or maybe just kind of talk through what we've got here?
Well, that's I think we might just skip the code part and come back to it after we get the application running.
Yeah, that's a good idea. I've kind of opened up the the appropriate folders
so
here in the
maybe just we show
Explorer.
where to look for stuff. It's spelled out in the README anyway. But
That's right. But this is where, if you wanted to see what the code that's kind of behind this, you can check out shows and genres.js, and it'll kind of have that
so
there.
The important thing is the distinction between the React components, which render the page and query the serverless functions, and they might even not know what GraphQL is. They just ask, get me the shows. And the serverless function will, in turn, they are in the functions directory, which is separate and will not make it into the client compiled code or bundled code. The serverless functions, in turn, will need environment variable to know where the GraphQL server is, and they will actually issue GraphQL queries. If you look at the code in the serverless functions, there you will find the same strings with the full GraphQL queries that we have been running so far in the playground. Maybe that's a good starting point, and then go looking at the README for more, or come to us Discord, for example.
Yep. All right. So next, what we're going to do here is we're going to go ahead and make this app aware of our database. So what I'm going to do is I'm going to Control-C out of this. I'm going to make sure that I have my my token copied. And I'm going to run this command called ASTRA setup. Now, what this is going to do is invoke the setup for the ASTRA CLI, and in doing that, it's going to help us create a lot of things on the back end that we'll need to kind of tie what we've done here out to our AstraDB instance. So where it says enter an ASTRA token, I'm going to paste in, and I'm going to allow pasting my brand new token here, and I'll press enter there. If everything worked, you should see this configuration has been saved message come back. You could even do like a Astra DB list, and it should show that we have the workshops database there, and you should see your database ID. But what we're going to do now is go ahead and create an environment file that's going to allow this database connection here. So I'm going to go ahead and do this ASTRA db create -.env, and I'm specifying the workshops database and then a -k intro GraphQL for the key space. So if I paste that in here, all right. So what that did is it created this this env file that I can actually open up here, and you can see it has like my token and some addresses and things based on my database ID. Now the other thing I'm going to need is that we have this local backend env file. We're going to make sure that we also send that, the contents of that, into our .env file as well. And I'm going to use the double redirect symbol to make sure it appends that to the end of that .env
So that's
file.
a trick to have the .env file also know of the local address of the locally running backend. That's a trick. But future versions of Astra CLI probably would just honor the pre-existing environment variables in a pre-existing .env. So that should be, the step should be going away at some point. Less complications for you.
Let's see, and that should be pretty much it. So now that I have that file there, yeah, I don't need to source it. I should just be able to run netlify dev, and I should be good.
When you run netlify dev, it picks up the .env and just injects the variable in the environment of the serverless functions for you. If you check the code of the functions, they will read environment variables for address and token and just issue requests with those.
Yep. And now when I look at our browser over here, you can see I still have our local stuff, but now our reference list by database worked.
Nice.
But our reference list by shows didn't. Wow.
I don't know. Maybe we got something wrong.
No, I think we just haven't created that schema or loaded the data yet.
You just created the reference list table, and that's all good because it works, and the full query works and gets the data back to the client. But you never created the table on the Cassandra on AstraDB. You never created the table for shows. And how do you create that?
Right.
Try to guess.
Well, I bet if I go down, here we go. That step 9F, that create the missing table. Look at that. So we have our create shows to. I opened up the markdown language.
Okay.
My bad. All right. So if I select that and copy, and now I have to jump back over to the GraphQL playground here. And I'm actually going to need to be in that GraphQL Schema tab. Can I do 2 of them here? Oh, it didn't like that at all. Let's see here.
You should just be able to paste the mutation that creates the table into the Schema tab.
Yep.
Playground tab. That should be
there. We go.
And then you can run it, and it should create another table.
Oh yeah, there we go. Yep. So let me go ahead and run this one for create shows table.
So this.
Oh, didn't like that. Clone anonymous operation value.
Wait a second. Create shows table.
I wonder if
you take the first out, maybe, but that's.
Take the first out.
Okay, so that's interesting. Let's keep a note and try to look it up more later.
Yeah. No, good call. All right, so I've done the create shows table. But now let's go ahead and add some data into that table. So if I scroll down a little bit more, you can see that we have a mutation here for inserting shows, for the shows Stranger Things and for Ozark. If I just go over here and hit that copy button, and then back to the GraphQL playground. Again, make sure that inside the GraphQL playground, you're on that GraphQL tab, since we're not worrying about schema at this point. And we can put that insert shows tab on the bottom there. And we can run that and say insert shows. There we go. Stranger Things and Ozark look like they've been inserted. Then if I go back to here and maybe hit the refresh here, hey, look at that! Shows by name in the database. We have 2 entries.
Nice.
How about that, huh?
It works. Yeah. Okay.
All right. And you can play around a bit more. You can put your own shows in there too. Let's see. And I think that's
that should be it. Now, this little, how do you say, gimmick of the error and then having to correct it was also there to highlight one thing. Now, of course, this is luckily has disappeared from the client, but let me go quickly back to the error you would see when you try to query a non-existing table. You get an error of type validation error. That's interesting because it's not like the table does not exist. It's not a table, it's not an error that says directly, oh, table not found. It is a validation error. What does that mean? It means that the symbol, the field called show by name in the type query is undefined. It means that even at schema validation level, this query fails already. That's because, again, yeah, so I see a question by Gleb. Is it right? That should be Gleb. The error is, okay. Did you by chance run the query on the GraphQL playground tab instead of the schema one? So you first make sure you are running that in the GraphQL schema tab where you meddle with okay, that was it. Yep. Great. Okay, so back to us. You see a validation error because, again, everything starts with a schema. So what happens is that a query that tries to read shows by name table will just not even get executed. It will break at validation level before execution because the schema does not know of that table or that field in general GraphQL parlance. The point is that, okay, if you were the one writing the application, the API, you would have either have it or not explicitly spelled out in the schema, this field. Now, the GraphQL on top of the database, on top of AstraDB, is a little different because it has to have a dynamically generated schema obtained by looking at the tables that exist. But the principle is the same. If the table does not exist for you, it is exactly the same as a schema that is missing a given type of query that is not available. So if you try to run it, you will just get a validation error because in the GraphQL specification, there is a whole lot of validation. There is a big validation layer that prevents malformed or non-existing field queries from even being attempted to run. So, okay, that's just to conclude on this point. You know, Aaron, it's 10 minutes, so we might wrap up and close. And again, sorry?
Yeah, I think, oh yeah.
Okay.
Oh, no, I'm agreeing. Yeah, it's probably time to get
so
up.
For more, please get in touch on Discord, and also there are more resources and more hints on where to look for as far as code details of coding are concerned in the README, in the GitHub. So please go ahead, and in the meantime, since we don't want to get late, let's just conclude with a few closing notes, and then don't forget there's the quiz coming. So make sure in the meantime, while I speak, I'll drop again a link to connect to the Menti game if you want your chance to win some swag. which is now. So please, that was a surprise. I thought that was after the last slides, but even better, let's jump to the quiz now. Okay, so, okay, most of you are connected already, but I'm struggling to get full screen. Let's see, quiz time. So please.
Hey, there we go.
Let's give a little time for everyone. So you join menti.com and you, okay, I have to move you around again, Aaron, sorry.
Oh, no, that's okay.
So join us on Menti, and if you paid attention, you will find the questions are not so difficult. So make sure you get them right, but of course, make sure you answer fast enough to beat everyone else and be awarded your well-deserved swag. Okay, so yeah, someone is still joining, so we wait. We can afford one more minute of waiting. So please. I think the swag nowadays is a t-shirt plus some other goodies. I'm not sure because we rotate.
Yeah, t-shirt and maybe some stickers or something.
Maybe.
Yeah.
We'll see. Okay, so looks like we can start. Okay, so let's start with the quiz. I'm going to move you back to your right place here. Okay, so I see people joining still, so maybe question number 1. Answer fast to get more points. What is GraphQL? Remember not to look at YouTube because there's a delay. GraphQL is a query language. It is a server-side runtime, or it is both things together, or it is something you plot data on, like D3 for Node. What is GraphQL? Let's see. 3, 2, 1, time's up. It is a query language and a server-side runtime. So I hope we stress this fact enough. It is both things. It's the language and the specification on the server structure. And this has now gives us a leaderboard. The Hustler is leading, Ribbit and Gleb, 3rd position. Okay, so I tell you already the first 3 positions will be winning swag. Question number 2. Answer fast to get more points. Is GraphQL strongly typed? That should be easy. No, or it depends.
Yeah, I think covered this pretty
yes,
good.
It is. Or maybe only if it takes protein powder.
Ooh.
Let's see. Now, this is an important point. And the answer is yes. Glad to see this. Most of you got it right. So GraphQL starts with a schema, and the schema has to spell out explicitly all types available and their type, or all variables or objects and their type. So most of you got it right. And yeah, so oh wait, Ribbit was replaced by Skylake, but it's still Frog. Nice. Okay, so question number 3, and we are more than halfway through the quiz. So, but still everything can change. What is a main feature of GraphQL? It has declarative queries. It has a lot of X and Y's as a graph, like a plot. It has a decreased network load compared to other APIs, or it has multiple endpoints. Let's see.
Well, this is a tough one.
Okay. There are 2 right answers. It has declarative queries, and also it helps decreasing the network load. Many queries collapsed into one. You can project out fields that you don't want. Something that it doesn't have is X's and Y's, because that has nothing to do with plotting graphs on a Cartesian diagram, and it doesn't have multiple endpoints. It really has a single endpoint, which is a defining feature in a sense, especially compared to REST. Okay, but most of you were not fooled by this question, and There are tiny changes. Sarang jumps to second position. Okay, so let's go on. And question number 4,
leading.
press enter. Here, sorry. I was surprised. Answer fast to get more points. So what is AstraDB? We use that, we played with that, we showed that to you. It is a managed Cassandra with API and tools, or it is a local in-memory version of Cassandra. It is a cloud-based IDE, or it is a beer brand. AstraDB beer, maybe. Let's see. Yeah,
that's kind of catchy.
Yeah. Okay, it is a managed Cassandra with API and tools. Almost everyone got it right. That's great. Well done. And this is Astra the beer, but it has no DB. So this is something that is pretty popular close to where I live. Okay, so I don't want to. Yeah,
I did not know that was a real thing. That's
Germany,
awesome.
You know? Okay, so let's see. Gleb fastest jumps again to second position, and that's really a surprise. Sarang maintains the third, and Skylake leading. And now get ready for the last question.
Yep. Last one.
Answer fast to get more points. In GraphQL, how do you change data or execute actions? You do insert or update, you run a transform, you run a mutation, or you run a variation. So what do you do when you change stuff on the server, basically, as opposed to just asking for data?
I think we hit this one pretty hard. Yeah,
that's great to see. So we did a great job, Aaron. It's a mutation. Well done. So let's see the final leaderboard at this point. It looks like Skylake is the winner. Congratulations. Gleb and Sarang, second and third. Congratulations to you all. And actually, congratulations to all of you who stayed with us so far. And of course, the main prize is your knowledge, because now you can go ahead and start your GraphQL journey. In the meantime, for the first 3, don't forget to, and that's very important, take a screenshot of your phone with the winning screen. Not of YouTube. Take a screenshot of your phone. I'm going to leave this up, especially if you are the first, second, and third in the list, because then, let me go back to my slides, then you will be able to claim your prize. And to do that, I'm putting in YouTube as well as on screen instruction on where to go to fill a form with your screenshot of your winning, and you will just give us your email, and we will give you a link to go and claim your prize delivered to you wherever you are in the world. So congratulations again. I'm going to leave the Menti again a little more for you to make sure you grab a screenshot. Now, we mentioned at the beginning that there is a homework. Now, the homework is very simple. It's described in the README. You have to insert a new show or a new genre of your choice, take a screenshot of that working in your application, and submit it to us. The homework instructions are in the GitHub repo. So we will be reviewing them by hand, one by one. So give us a few days to do that, and you will win your badge, which you can then, show around to make everyone else feel jealous. So something that we want to remind you again is this YouTube chat is going to disappear with the live in a few minutes. So make sure you join us on Discord, because that's where the discussion can go on for GraphQL queries, Cassandra-related queries, or, well, many other things. Please connect with us, and we will be there ready to help you. Of course, we would like also to invite you to like our channel and to follow us on YouTube, because that's where we keep doing workshops, 1 per week. So if you're interested, please stay with us. And there's a very important thing for you all.
Oh yes, the Cassandra Summit is back.
After a few years of stop, we are rebooting the Cassandra Summit, and this year is going to be in person in San Jose in March. Well, in person and virtual, right? Both. So if you are interested in Cassandra, you want to come and show us what you are building with Cassandra, or just want to attend, please join us. It's going to be a great party with a lot of knowledge, learning sessions, training sessions and talks and a lot of things. And in particular, the CFP is closing in, 3 weeks from now, more or less. So make sure, you submit on time. We would love to hear from you.
That's right. Any of you using Cassandra or Astra, we would love to hear about it. And, folks would find that really interesting if you put that into a talk.
Did I mention that if you get your talk accepted, you are going to be free? You're going to be given a free entry ticket. Yeah,
I don't know if we mentioned that, but yeah, that's a
okay. So yeah, that's our YouTube channel. We are the DataStax developers. I think for now, for today, we have reached the end. Maybe I can just move to, if I manage to. That's probably too late. Okay. So I'll just have Menti show you a free form if you want to give us any feedback, honest feedback, constructive feedback to improve, to help us improve next time. Yes, I think that's it for today. I hope it's been fun, entertaining, and of course instructive. I hope you've learned a lot, and there's no better way of learning than doing things. So today there was a bit of hands-on, so I hope it's been fun for you and useful. I think it's time to say goodbye. Maybe see you the next time, right? So
all right. Hey, thanks everyone. We'll see you later.
And as always, don't forget to click that subscribe button and ring that bell to get notifications for all of our future upcoming workshops.
In a being gifted with powers from the goddess of Cassandra, who grew those powers until she could multiply at will, move with limitless speed, and unmask hidden knowledge. With those powers, she was able to fully understand the connectedness of the world. What she saw was a world in need of understanding. From that day forward, she sought to bestow her powers on all who came into contact with her, empowering them to achieve wondrous feats.